Welcome to another exciting video on the fossil record. My name is Benjamin Berger, and in this video I wanted to do an update on a previous video that I did on megafauna extinctions and discuss the discoveries made since I recorded it. In the previous video I discussed three hypotheses to explain the megafauna extinction that occurred between 12,000 and 9,000 years ago in North America. This extinction led to the disappearance of mammoths, mastodons, giant camels, horses, saber-toothed cats, glyptodons, and giant ground sloths. Now, one theory I discussed was the impact hypothesis, in which a large asteroid or comet struck the northern hemisphere during this time and caused the extinction of these iconic Ice Age mammals. When I recorded the previous lecture 2 years ago, there was very little evidence to support the impact hypothesis. And this is because there was no record of an impact crater. The only evidence at the time was some charcoal layers that were dated to around that time, and whether there was evidence of nanodiamonds that were deposited during that time. So there was not much support 2 years ago for the impact hypothesis. However, since I recorded that video, an impact crater has just been discovered, and so there is new evidence to re-examine this question. The crater was discovered by a Danish geologist named Kurt Kajar, who works at the Natural History Museum of Denmark. And it opens the door on this theory once again. The crater is located beneath the Hiawatha Glacier along the northern coast of Greenland, a remote place, but one that's actually people have visited before. In fact, what sparked Kurt Kajar's interest was his museum's iconic large iron meteorite, which had been found in northern Greenland and displayed at the museum. And he had long suspected that a crater might exist near where the meteorite had been found. So he pored over maps, particularly looking at maps made by NASA's ice-penetrating radar. But it was too difficult to really see if there was a crater beneath the ice of the Greenland ice sheet. Around the same time, the German Alfred Wegener Institute for Polar and Marine Research had purchased the next generation of ice-penetrating radar. And the museum realized that it could use that equipment to scan this region and map the topography below the ice. However, the museum needed money to finance such a study. And this is where Danish beer comes to the rescue, because Carlsberg Beer actually funded the research to pay for the ice-penetrating radar to survey the region below the ice. And when they did so, they discovered a massive crater. The crater is 31 kilometers in diameter, about 20% the size of the massive KT boundary impact crater that killed off the dinosaurs. So it's about half the size of the late Eocene Chesapeake Bay impact crater in Maryland. But it's 20 times, so quite a bit larger than the size of the meteorite crater site in Arizona. So it's large enough for a major disruption of the northern hemisphere, but it's not a major global killer like the asteroid that killed off the dinosaurs. So it's kind of exactly what supporters of the impact hypothesis were hoping to find. Now, one thing we don't know as I'm recording this in this video is the age of the impact crater. This will require additional research. But many scientists are predicting an age around 12,900 years ago because of some squirrely things that we see in the sediments and ice cores of Greenland during that time, something called the Younger Dryas event. So when paleoclimatologists looked at pollen in sediment cores drilled through the last glacial and interglacial cycle in Greenland, they noticed some interesting things. They noticed that the pollen of the Dryas flower, which is a plant that enjoys colder climates, disappears. So there's a band where it disappears, and then there's another band in the sediment core where it reappears again. So the older section of the core, they call that the older Dryas event, which is equivalent to the last ice age. But the band of absence and then the band of presence again indicates the younger Dryas interval. And this interval of time is a period of time in which the climate shifted back or started to cool down from its initial warm-up. And the younger Dryas event lasted from about 12,900 to 11,700 years ago. Climate scientists have debated the cause of this short-term global cool down. Some have suggested that there was an influx of less dense freshwater in the North Atlantic that slowed the warm waters of the Gulf Stream from reaching Greenland. Now, this is the textbook theory, the one that I teach in my introductory geology classes. However, such cooling could have been caused by an impact event, and it may have affected the animals living at that time, including the humans living in North America, as the continent was populated back then. In fact, there are some new discoveries pushing back the date of North American human occupation. The Hoya Negro human remains from the Yucatan Peninsula of Mexico have recently been dated to this particular time period between 12,910 to 11,750 years ago. They are the oldest human remains in the Americas. Older evidence has come from the Blue Fish Caves, which is a site in the Yukon, in which horse bones show butcher marks dated to even older dates of 24,000 years ago. If these dates hold, humans entered into North America much earlier than we had thought previously, before the younger Dryas event, around 13,000 to 14,000 years ago, during the initial warming period of the beginning of the interglacial cycle. This is the first warm zone in which the pollen of the Dryas flower is absent in Greenland. So it's during this initial warming period that humans were finally able to penetrate through the great ice sheet that covered North America, as it was just beginning to retreat at the very end of the last ice age. So humans were entering into North and South America in small numbers at this time. And if we can get some dates on this crater, there's a possibility that at the same time that these early Americans were traveling southward, they witnessed an asteroid impact in the northern hemisphere in Greenland. This makes things complex, because which of these coeval events caused the extinction of the megafauna? Was it the impact of an asteroid? Was it climate change? Or was it the arrival of humans? As these dates have been getting older for the earliest human occupation of North America, so too have the dates been changing of the last mammoths and mastodons and other Ice Age mammals. They've been getting younger. The overlap of the first humans in North America and the last of these iconic Ice Age mammals has been getting wider, suggesting a longer history of hunting in North America of these mega-mammals by humans, and bolstering support for the extended overkill hypothesis. Most of the extinctions of these large mammals occurred around 11,000 to 10,000 years ago, with a few species extending into 9,000 or 8,000 years ago, mostly in refugia, in places where humans did not live or hunt. This means that for 4,000 years, populations of these iconic North American but tasty mammals were declining as human populations grew and hunting pressures increased. Now, most of these iconic large mammals died out after the Younger Dryas event, and once global temperatures had actually stabilized around 10,000 years ago. So the one thing that was changing at that time was human populations. They were growing. And there is lots of direct evidence of hunting of these large mammals during this period around 10,000 years ago. One example are stone tools, which have been dated to 13,000 years ago from Boulder, Colorado, that preserve giant camel DNA. Human bones from Southern California, Idaho, Nevada, Washington have dates between 11,000 and 9,000 years ago. The last mammoth skeletons from Lango, Ferguson, South Dakota, Kobe, Wyoming, Dent, Colorado, and Dumbo, Oklahoma are found with Clovis points, showing active hunting and butchering of mammoths in North America from 11,000 to 10,700 years ago. Now, all of this indicates a growing population in America during this later period, when the advent of the Clovis spear points, hunting large mammoths provided subsistence to these people and allowed them to flourish in a new world until their extinction and the advent of agriculture around 5,000 years ago. Now, one thing to mention that I encountered when I was doing this research is that radiocarbon dates, carbon radiometric dates, are often reported as either calendar dates or C14 radiometric dates. So, for example, a skeleton might have a C14 radiometric date of 11,000 years, but a calendar date of 13,000 years before present. So which one of these is the correct one? Which one should you use? So the assumption of radiometric carbon-14 dating is that the amount of carbon-14 in the atmosphere has remained constant. But studies looking at tree rings, annual tree rings, have shown that this assumption is not completely true. So the amount of carbon-14 in the atmosphere does change. So to account for that change in the initial amount of carbon-14, scientists apply a correction, which typically corrects the age to an older date. So in this video, I am using calendar dates, often abbreviated PB, before present, or years before 1950. In this video, whenever possible, but sometimes it was not quite clear in a published study which one was being used. And if you're not sure, you could be off by 2,000 years, and it could really affect your conclusions. You may be wondering why we use 1950, and it is because of this. Yes, it screwed up the amount of radioactive carbon-14 in the atmosphere, so you can't determine the radiometric carbon date of something younger than the advent of the atomic bomb. Thanks for watching, and I hope this answers some of the questions and comments that I've been receiving on my previous, now out-of-date video. So I want to thank my Patreons, Brian Clever, Pablo Luzato Figuez, Arcodus 1811, Justin Bovey, and my Trilobite supporters for encouraging me to make these extra videos on the fossil record. If you'd like to support this video, check out the link below and let me know if you have any suggestions for future ideas or future things I can talk about in these videos. Thank you for watching.